In this crowd, someone whispers that one of them is a vampire. Can you find this bloodthirsty creature? Should we try garlic bread? Hold up a mirror? According to the internet, vampires have a lower body temperature than normal people. Oh, then we could use a thermometer. But they probably won't let you put it in their armpit, or in their mouth, or... So we need something better. We need a thermal camera. Now everyone suddenly glows in warm yellow-orange colors, meaning they're around 37 degrees Celsius, real human body temperature, except for one. She's bluish, almost blending into the background at only 18 degrees Celsius. And we've found a vampire. In the Yorktown battlefield, a French king's white bourbon flag waves in the wind. That's because French royal troops fought alongside the Americans. The white royal color traced back to medieval tradition and was made iconic by Joan of Arc, who carried a white banner as a symbol of divine purity and rightful kingship. For centuries, people believed white was the purest color. Yay! Until Sir Isaac Newton proved they were all wrong. Here's a prism in my backyard. When white sunlight passes through it, the beam separates into different colors. This phenomenon is called dispersion. The colors appear in order: red, orange, yellow, green, blue, indigo, and violet. A rainbow forms the same way. When sunlight meets water droplets in the air, the light is reflected and refracted into its hidden spectrum. But what if you don't have tons of money for a prism? I've got a baking tray filled with water and a white board in front. I placed my very pretty mirror at an angle so its lower part is submerged. Well, any plain mirror will do the job. Then I slowly adjust the tilt of the mirror, and there it is, our rainbow band. The sun's energy reaches Earth in the form of light. The rainbow band we observe is the sun's visible spectrum. But is that all the sun sends us? I place a little pointer right at the edge of the red region. Now I turn on the thermal camera. The hottest spot appears beyond the red, on the left side of the pointer. Something invisible is landing there and warming it up. That invisible something is infrared light. Infrared lies beyond the red end of the visible spectrum. And it's not just the sun. Every object gives off infrared. A normal camera captures visible light, but a thermal camera or infrared camera detects infrared. Yellow and orange show stronger infrared, meaning higher temperature. Blue and purple show weaker infrared, meaning cooler objects. After I remove the two water glasses, only a little watermark is left, but the infrared still reveals exactly where each glass was sitting. Press your finger against a wall and slide it across. You're painting with heat. The warmth from your skin transfers to the wall. Now imagine an alien predator with infrared vision hunting for you. How would you hide? Behind a curtain? Nope. Wrapped in a black trash bag? Still nope. How about inside a thick down jacket? Nope. Behind glass? Oh yeah. Then if I look through my window using the thermal camera, I shouldn't see anything outside, right? Wait, I see myself, just like in a mirror. That's because most of the infrared light coming from my body bounces off the window glass. If glass works, what about metal? Here I have a metal plate The surface is rough, so diffuse reflection dominates. The light scatters in all directions, and I can't see my face in it. With infrared, it becomes a mirror again. For infrared light, the wavelengths are much longer than visible light, so the tiny bumps and scratches on the metal don't scatter the infrared effectively. Does everything in the universe have an opposite? For every peak, a valley deep. For every wake, a silent sleep. The burning sun, the freezing ice. A heavy cost, a tiny price. Each thing that is must also be bound to its twin eternally. Beyond the red, the warm infrared. Beyond the violet, the ultraviolet rays hide. In front of us, we have tap water, tonic water, and olive oil. A regular flashlight covered with violet paper giving us visible violet light, and a UV flashlight which produces a faint violet glow plus invisible ultraviolet light. First, we shine the regular light. Everything looks normal. Now we switch to the UV light. The tap water stays the same. The tonic water glows bright blue. The olive oil turns a deep, dark red. So there must be an invisible light beyond violet. While ultraviolet produces fluorescence in certain chemicals, tonic water contains quinine molecules and olive oil contains chlorophyll. When invisible UV light shines on them, these molecules absorb the high-energy UV and jump to a higher energy level. As they relax back to their original state, some of that energy is lost as heat, and the rest is emitted as lower energy visible light. A dollar bill, laundry detergent, and many other things glow under ultraviolet light because of fluorescence. UV carries enough energy to excite the fluorescent materials inside them. But that same high energy also gives sunburns and damages the DNA in our skin cells. So don't forget wearing sunscreen on a beach day. This is Dr. Walden from Graceful Science. Let me end this episode with a question. What will happen when a green laser shines through olive oil?